Hey guys, welcome to the Maths Club again. Today we are going to be looking at a one-time video on positive and negative integers and rational numbers. This particular topic does not have WAEC past question with it. So if you have not subscribed to our channel, kindly hit the subscribe button and let's get started. We're going to be looking at integers, positive and negative integers, natural numbers, rational numbers, and the 4 basic operations on rational numbers. For integers, what are integers? Integers are like whole numbers. So the number that you see when you see minus 5 is a whole number. When you see 1, you see 3, you see 20,000, those are whole numbers. So any whole number, whether positive or negative, is an integer. So it says that an integer is a number that is not a fraction. Basically it is a whole number, and this includes 0, positive and negative whole numbers. So it says the set of integers, right? There's a denotation for integers called z. When you see z, you see z is equal to a set of something, you know that they're talking about integers. It's formally declared, as you can see. It should be, you can continue dot dot dot. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The dot 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 simplifies that. It keeps on extending. Integers are represented on a number line. So if you ever seen a number line before, you will see that, let me see, I think we have a depiction here. So you can see this is the number line here, and this middle point is the 0. So you can see just like a graph. Remember your graph sheets. So this 0 position, of course, is an integer, and 0 is neither positive nor negative. And you can see to the left of 0 is the negative integers, and to the right of 0 is our positive integers. So whenever you see something like this that consists of only whole numbers, and a number line like this is called an integer number line. To the left of the 0 is negative integers, to the right is positive integers, and 0 is neither positive nor negative. So this is the integer represented on a number line with positive integers to the right of the 0 and negative integers to the left of the 0. So that's basically it about integers. Now we're going to natural numbers. Natural, when something is natural, it means like it's just free flowing, like it's not artificial, it's not fake. These are the natural numbers that we have. So natural numbers are really known as counting numbers. So when you want to count, what do? Naturally, they say what are the numbers that you want to count sometimes, but you will not be saying minus 1, minus 2, no. Naturally, you will say 1, 2, 3, 4, 5. So all those 1, 2, 3, 4, 5 are really just counting numbers. You can see natural numbers, also known as counting numbers, are a set of all positive integers that begin with 1 and extend infinitely without any upper limits. So naturally, when you want to count, you start from 1 and on and on and on like that. I know it's programmers that always start from 0, right? But this is naturally to the common man. It all starts from 1. So how do we represent natural numbers? It's very symbolic. Natural numbers is represented with n natural, and is defined as, you can see, starting from 1, 2, 3, 4, 5, 6, and all the way up till infinity. Natural numbers include all the whole numbers excluding the number 0. You know, I said something that naturally when you want to count, you start from 1. So the counting numbers is known as natural numbers, denoted by n. Can anybody tell me what we denote integers by? Great, we denote by z. Natural numbers are placed to the right of the 0 on the number line as they are positive integers. This makes sense. So if you see our number line, you will see that to the right of the 0 up to this place, we're talking about whole numbers. But when we come from 1 to the right, we're talking about natural numbers. When we're talking about rational numbers, rational, what does it mean? Rational, if you look at the word, rational has a bit of ratio in it. And when we talk about ratio, we say 1:2, or basically what we're talking about is fraction. From this big $1 million that came in, my portion is half. They're saying a ratio. So out of 2 portions, you're taking 1. So 1 out of 2, or 1:2, or 1/2. So we're talking about rational numbers, talking about ratio, and it's denoted by Q. So whenever you see Q, you're talking about rational numbers. I think the Q can even be symbolized as, you can think of in terms of quotients, just to make you remember. Say quotient. Yeah, so Q represents rational numbers, and they can be expressed as fractions, a over b, and of course a and b have to be integers, and b is not equal to 0, because if b is equal to 0, you're going to be having math errors, just like you have 1 divided by 0. 1 divided by 0 is math error. So rational numbers are denoted by Q, and then the numerator and denominator, they must both be integers, and then the denominator must not be 0. Numerator, I mean the value at the top. Denominator, I mean the value at the bottom. They represent values that can be represented as a ratio of two integers. Rational numbers can be presented in both fractional form, in form of 3 over 4, or as decimal. So you see 0.5. So if you look at 3 over 4, that should be 0.75. So if I represent 3 over 4 as 0.75, I'm still talking about the same thing. Rational numbers differ from irrational numbers. So you can see there's irrational. When somebody is irrational, I mean that's something else. That adds a different meaning in English. Irrational numbers are numbers which cannot be expressed as a simple fraction. So an example is the square root of 2. So how can we say square root of 2? Square root of 2 is a value that has, look at it, 1.414 something. If you do square root of 3, 2. All these irrational numbers, most times we're always going to be dealing with, most of them are actually surds. I think that's the next topic we're going to be talking about. Right, so you'll be seeing a lot of irrational numbers as surds. So the rational numbers are different from rational, because if we see, you cannot do root 2 and say root 2 as a fraction, because the value keeps on going very, very long. Can continue. If you have a calculator that can span up to 1 million words or 1 million letters or numbers, you will see that you'll be having 1 point something. So you cannot really express that as a fraction. That's why it's called irrational. I mean, does not is entering the realm of the crazy, right? So that's basically it about rational numbers. And if you look at it on the number line, so in between all our whole numbers or our integers, 0, minus 1, minus 2, minus 3, in between them, you are going to be having, you can say minus 3.5 is somewhere between minus 3 and minus 4. Minus 2.25 is between this guy. So all of these numbers that can be represented as fractions, all these dots, they are what we call rational numbers. So there are 4 basic operations that we carry out when dealing with rational numbers. So look at them: addition, subtraction, multiplication, and division. So for addition, it says addition is a fundamental arithmetic operation that involves combining 2 or more rational numbers, fractions, to obtain a single rational number as a result. So we have a over b plus c over b. Because they share the same denominator, we bring out that denominator, and I mean, this is not something new, but there's a trick that I'm going to show you. In this place here, they are different denominators. So you can see the denominator of the results was the combination of the 2 of them, or the lowest common multiple, and then we did all of this. That is not strange. So subtraction, same thing. So but I find the difference between 2 or more rational numbers, same concepts. Multiplication, so to multiply, you multiply the numerators together to obtain a new numerator, and you multiply the denominators together to obtain a new denominator. Remember, I said there's a trick I want to show you. Same thing to here, and same thing applies to here. And for division, you multiply the first number, which is the dividend, by the reciprocal. Reciprocal is like the inverse of the second number, which is the divisor. So you have a over b divided by c over d. You have to first take the inverse of the second guy, right, which is the divisor, and then you now say a times d over b times c. So for an example, we're going to deal with 3 over 4 with 1 over 2. I'll use this example to actually show you the shortcut I'm talking about. So if I had 3 over 4 plus 1 over 2, ideally, first thing I'll say, we'll just say lowest common factor is 4b. 4 in 4, 1 times 3, 3, plus 4 in 2, 2 times 1, 2. I will say the answer is 5 over 4. But this might be a longer process. If I have 1 over 2, and I multiply the top by 2, and I multiply the bottom by 2, I would have 2 over 4. Is this the same thing as 1 over 2? Yes, it is, because I did the same operation to the top and to the bottom. Like, you can always multiply the top and the bottom. You can't add. If you had, that is something different. You're going to add, but you can multiply both the numerator and denominator by the same value, and then you still have the equivalent. So this guy is 3 over 4. When I multiply the top and bottom by 2, 2, both of them both add 4, 4. So what am I saying? I'm saying this is 3 over 4 plus 2 over 4. Now this is easier to do. Since they have the same denominator, I'll just add the numerator, which is at the top, and say 3 plus 2 is 5. 5 over what? Over 4. Very simple. So if I had 3 over 8 plus 1 over 2, this is like saying 3 over 8 plus 1 times, what can I multiply the denominator by that will give me 8? So that will be 4. So 1 times 4 all over 2 times 4, and this will give me 3 over 8 plus 4 over 8, and I'll just add just the top, which is 7. 3 plus 4 is 7. 7 divided by 8. Simple and short. This also applies for subtraction. So if I wanted to do subtraction of these guys, I would just say 3 over 8 minus 1 over 2. Since I'm saying 3 over 8 minus what? 4 over 8. So 3 minus 4 is minus 1 all over 8, and this is my answer. Simple and short. So whenever you have addition or subtraction between two rational numbers, always try to make sure that they're the same denominator, so that you can just either just add their numerator or subtract their numerator. For this particular question, if you had 3 over 4 times 1 over 2, you don't need to bother yourself. 3 times 1 is 3, 4 times 2 is 8. And if I had 3 over 4 divided by 1 over 2, I'll just say 3 over 4 and find the inverse of the divisor. So times 2 over 1. So 2 here 1, 2 here 2. And this is 3 over 2. So this is basically it about addition and subtraction. I'm sure probably we already knew the trick, and if you did not know, you've learned something new. So with addition, we add 5 over 4, 1 over 4, 3 over 8, and 3 over 2. So with this, we've come to the end of this particular video on positive and negative integers and rational numbers. In summary, we said we denote integers by Z, we denote natural numbers by N, we denote rational numbers by Q, and then we talked about the basic operations that we can do with rational numbers. If you found this video useful, you can like the video, and if you have any question or any contribution or any correction, and drop it as a comment in the comment section. I will address all comments. See you guys in the next topic, which is sorts. Bye for now.